Hi children, this is Venkatanna. Today's class, 10th class physical science, we are discussing the concepts of acids, bases and salts. Acids, bases and salts. In the introduction class, we discussed what are the physical properties of acid, what are the physical properties of bases, and what are indicators we discussed. Generally in our daily life, where we will use acids, where we will come across these acids in our daily life activities. We will come across these acids generally for cleaning the washing the washrooms, cleaning the washrooms, and we can able to see that acids will be mostly used in the laboratories of schools and what we call colleges to do experiments. And also we will see that acids are useful little bit for the cleaning of for the what you call cleaning the tiles, etc., and for melting of gold for by the goldsmith. In this way, we'll come across these acids in our daily life. Not only that, in our stomach, what we call daily hydrochloric acids will be going on segregated, released, which will help us for digestion of food. Now, so in this way, what we call we come across acids in our daily life, knowingly or unknowingly. If suppose honey bee sting, what we call bites, they will get a huge pain because of that sting consists of acid, which is known as a formic acid, which will give the pain for us. Then it is better what we call to for the remedy for that one is to rub with soap or what we call to deal with base. As a result, what we call that acid will be neutralized and we will get rid of that pain. So in that way, we come across these acids in our daily life, knowingly or unknowingly. Now in this session we will try to elaborately define the what is the acid and how we will prepare the acids and what are the again once again physical properties and chemical properties of acids and what are the various different types of acids and what are the formula of acids we are going to discuss. Now generally how to define an acid, how to define a base, how to define a salt. There will be no particular definition for the acids, bases, and salts. But what do you call the first scientist, the first chemist who tried to define the this acids, bases are nothing but Arrhenius. What is his name? Arrhenius. He tried to define the acid. He said that any substance which will dissolve in water, and release and liberate H plus ion is known as a acid. So what he said and what is an acid means? Acid is a substance which will dissolve in water and liberate H plus ion or release H plus ion. That is known as a acid. In that way, he tried to define. And similarly, he tried to define the base as a base is a substance which will dissolve in water and gives rise to OH minus ion. That is a base. In that way, he tried to define. So, who tried to define that one? Arrhenius. His name is Arrhenius. So, what Arrhenius? Who is the scientist first to try to give the definition of this acids, bases? Arrhenius. Okay. What did he try to define that one? He tried to define that acid is a substance. Acid is a substance which dissolves in water. Substance which dissolves in water, and liberates or release H plus ion. In that way, try to define the acid. We also try to define the bases. What did he define acid? What are Arrhenius acid? Similarly, Arrhenius base. According to Arrhenius, what is meant by a base? Now, according to what we called this base, what base is a substance. Base is a substance which dissolves in water, and liberates and and liberates OH minus ion. OH minus ion. In that way, we try to give definition for the acids and bases. But this is definition of acid bases consists of mainly two limitations. Mainly two limitations. What are the two limitations? He considered the only substances which can dissolve in water. Which can dissolve in water. But means which can dissolve in water and can able to release H plus ion are only considered as acid. But what about the substances which cannot dissolve in water but have consisting of acidic properties, but have acidic properties? That means according to Arrhenius definition, we can't consider the substances which cannot dissolve in water and which can be dissolved in other liquids, and also can have what we call H plus ion. And so if they can able to show acidic properties. That's the first limitation. Second limitation is he considered only the substances which can liberate H plus ion in acids, but not the what you called substances which cannot liberate H plus ions, but what you call showing the acidic properties. In that way, for the definitions of the acid and bases, what you call just still we'll believe that Arrhenius acid definition and Arrhenius base definition only we are following. Now, how we will prepare the acids generally? How we will prepare the acids? Acids are generally prepared from the non-metallic oxide dissolved in water. Non-metallic oxide dissolved in water. That means which non-metallic oxides are acidic, what do you call as acidic oxides. So when non-metallic oxides dissolve in water, then we will get acids. So now we are discussing regarding how we will prepare acids. How we will prepare acids. Now preparation of acids. Preparation of acids. How we will prepare acids? See, non-metallic oxides dissolves in water gives rise to acids. So what are non-metallic oxides? Non-metallic oxides like sulfur dioxide, sulfur trioxide, carbon dioxide, phosphorus pentoxide, phosphorus trioxide. All these are the non-metallic oxides which will dissolve in water and gives rise to acids. Now, generally, sulfur trioxide, how you will get? Sulfur burning in presence of oxygen gives rise to sulfur dioxide. That sulfur dioxide, again what we call oxidize when you expose to what we call air, then it will become a sulfur trioxide. So in the atmosphere, first sulfur, combustion of sulfur, means burning of sulfur gives rise to sulfur dioxide. As then that sulfur dioxide once again oxidized because of what we call exposure to the atmosphere, then we will get sulfur trioxide. So non-metallic oxide, sulfur is a non-metallic oxide plus water, we will get H2SO4, which we will call it as sulfuric acid. What do you say? Sulfuric acid. Next, suppose sulfur dioxide, then what will happen? Plus water, we will get sulfurous acid. Now, it is known as sulfurous acid. This side. Now, balanced or not check. One sulfur. 3 oxygens plus 1 4 oxygens. 2 hydrogens balanced. Here also let us check whether it is balanced or not. 1 sulfur. 2 plus 1 3 oxygens, 2 hydrogens. In that way, we have what we called this sulfurous acid. Similarly, if you have what we call nitrogen dioxide plus water, nitrogen dioxide, nitrogen dioxide plus water, or you can able to tell simply dinitrogen, dinitrogen trioxide, dinitrogen trioxide plus water, we can able to get HNO3, HNO2, nitrous acid, nitrous acid. What do you get? Nitrous acid, and also we will get what do you say? Here, let us check this balanced or not. Two nitrogens, here one nitrogen. So let us make two nitrogens. Then what happened? Oxygens 3 plus 1 4, 2 to the 4 oxygens. Two hydrogens, balance. This will call it as dinitrogen trioxide plus water. We will get what we call nitrous acid. What is this one? Nitrous acid. Nitrous acid. Nitrous acid. English nitrous acid. Next, suppose nitrogen dioxide plus water, it will give rise to nitric acid plus nitric oxide. Nitric oxide. It's a balance or not? Let us check that one. One nitrogen, 1 plus 1, 2 nitrogens. Let us make 2 nitrogens. Then what happened? Oxygens become 2, 2s are 4 plus 1, 5. Then 3 plus 0, what do we call the 4 only. So not balanced. And moreover, hydrogen is here 2, hydrogen is here 1. So what we will do? We'll make this 2 here. We'll make that 2. So what happened now? 2 nitrogens. Nitrogens, so how many are there? 2 plus 1, what we call them? 3 nitrogens. 3 nitrogens. So not balanced here. So what we can able to tell here? So 2 nitrogens here. Then we can able to write here. What do you say? Let us check that one. 2 2s are 4 plus 1, 5. 2 2s are 4 plus 1, 5. Then we can able to do it here. Suppose now, suppose if I write what we called 2s are, then 2 2s are 4, and 4 nitrogens we have to do. Then what happened here? 2 1s are 2 plus 2 2s are 4, 6 oxygens. But here 4 3s are 12 plus 1, many are there. So it's not balanced. So what we can tell that this is a nitrogen dioxide plus water. We will get nitric acid plus nitric oxide. Nitric oxide. Nitric oxide. So in that way, we can able to tell what we call how the acids are prepared. How the acids are prepared. Even we can able to prepare carbon dioxide plus water dissolved in water, we will get carbonic acid. What do you say this one? What do you call this one? This is nitric acid. Nitric acid. This is nitric acid. Now what about this acid? Carbonic acid. Carbonic acid. This carbonic acid is nothing but what we call cool drink, which we going on what we call drink that one. Cool drink. Carbon dioxide dissolved in water. So in this way we can get nitric acid, or else we may get what we call directly dinitrogen pentoxide. Dinitrogen pentoxide. Generally the reaction nitric acid we will get in that form, but now dinitrogen pentoxide plus water gives rise to HNO3. HNO3. Now we have to balance 2 nitrogens. 2 will do it. Nitrogens 2, 2 nitrogens. Hydrogens 2, 2 hydrogens. Oxygen 5 plus 1, 6. So this is known as nitric acid. Nitric acid. So in that way, non-metallic oxides, when they dissolve in water, we will get acids. That's why these non-metallic oxides are known as acidic oxides. What do you say? Acidic oxides. Similarly, phosphorus pentoxide, when dissolved in water, we will get phosphoric acid. phosphoric acid. This is phosphoric acid. Now, what is the phosphoric acid formula? H3PO4. Now, let's check is it balanced or not. Phosphorus 2, phosphorus 1. So, let us make 2 here. Then phosphorus 2, 2 phosphorus. Hydrogen, how many? 2, but here 3, 2, 3 are 6. So, let us make it 3. Then oxygen, how many become? 5 plus 3, 8. Then 2 4s are 8. So, in that way, balanced. So, we can able to tell that how the what you call acids are formed. Acids are prepared. Acids are prepared by the dissolution of non-metallic oxides. Non-metallic oxides. So, when non-metallic oxides dissolve in water, we will get acids. We will get acids. That's why these all are known as non-metallic oxides. What do you say? Non-metallic oxides. All these are non-metallic oxides are known as acetic oxides. What do you say? Acetic oxides. Why it is known as acetic oxides? Because when they dissolve in water, we are getting acids. That's why these are known as acidic oxides. Acidic oxides. In that way, we can able to prepare acids. So, how we can able to prepare acids? By the hydrolysis of non-metallic oxide. What is the meaning of hydrolysis? By reacting with water, by treating with water. To whom we are treating with water? Non-metallic oxides. That's why all non-metallic oxides are having which nature? Acidic nature. So, from this what we can tell? Therefore, all non-metallic oxides. Therefore, what we can tell? All non-metallic oxides. All non-metallic oxides have are which nature? Are acidic in nature. Acidic in nature. Why we can tell they are acidic in nature? Because they have when they dissolve in water, they gives rise to acids. So in that way we will prepare the acids. So how we will prepare the acids? Non-metallic oxides, when they dissolve in water, we will get the acids. Now, so let us what we call discuss about the formula of acid. Sulfuric acid formula H2SO4. Sulfurous acid formula H2SO3. Your maximum oxidation will take place. Whenever in any acid, maximum oxidation takes place, that will be starts with non-metal and end with ic. That means here it's a H2SO4 maximum oxidation occurred. What is the meaning of maximum oxidation occurred? H2SO4, let us check that one. Now we know that hydrogen, what is the oxygen valency? -2. That means 4 oxygen valency -8. Then sulfur valency +6. Hydrogen valency +1. Then 2 hydrogens valency +2. +2 +6 how much? 8. 8 plus 8 minus 8 how much? 0. That means how much oxidation should occur? That much oxidation occurred. That's why then its name will start with non-metal and end with ic. So in this way, its name is known as sulfuric acid. Sulfuric acid. Similarly, if I take this one HNO3, here also oxygen valency is -2, 3 oxygen valency is -6, nitrogen valency is +5, hydrogen valency is +1. Then what will happen? +1 + 5, 6. 6 minus 6, 0. That's the maximum oxidation occurred. As a result, its name will start with non-metal, which is known as nitrogen, and end with ic acid. So that's why its name is nitric acid. What is it? Nitric acid. Similarly, if you take phosphoric acid, H3PO4, what happened here? Oxygen valency is -2, 4 oxygen valency is -8, phosphorus valency is +5, hydrogen valency is 1, 3 hydrogens valency is +3, +3 more +5 +8, 8 minus 8, 0. That's why its name will start with non-metal, which is known as the phosphoric. phosphorus, and end with ic acid. So its name is phosphoric acid. Phosphoric acid. Now let us check about H2SO3. H2SO3. Now what happened to H2SO3? H2SO3. Oxygen valency is -2. Free oxygen valency is -6. Sulfur valency is 6. Hydrogen valency is 1. Then what happened to 2 hydrogen valency? +2. +2 + 6, 8. 8 minus 6, not 0. So complete oxidation not occurred. That's why it will start with the middle and end with as acid. As. So its name is sulfurous acid. What is it? Sulfurous acid. Similarly, if I take what you call nitrous, HNO2, HNO2, all these are end with ic acid, ic acid, ic acid, non-metallic acid, non-metallic acid. These will call non-metal plus acid. So what is its name? -4, 5, 1. 6 minus 4 is not 0. Maximum oxidation doesn't occur. That's why its name is nitrous acid. Nitrous acid. In that way, we'll have acid names. Whereas what we call in this session, just we discussed how the acids are prepared and what we call where we come across these acids in our daily life. In next class session, elaborately we can able to discuss now some other acids which it doesn't what to call the which won't take place in the hydrolysis process, which will take place by the direct combination of acids like a hydrochloric acid. Hydrogen plus chlorine gives rise to hydrogen chloride. In presence of water, it will acquire the hydrochloric acid. So in this way, in this session, we discussed about preparation of acids. Thank you.